with a comprehensive look at the transport layer from the modeling and simulation perspective, it is about time that we recap the session with associated problems and simulations. First, we look at some problems. These problems are for the students to consider, try solving them, and try to establish their relationship with the fundamental concepts. These problems would give you an insight into how the real-world systems are designed so that you can model them and simulate them in Omnet++. We shall recap today the problems which are related to Telnet if it uses TCP as the underlying protocol by default. And then we'd look at the TCP throughput problem. The reference that I've chosen is Top-Down Approach by Quiroz and Ross. Let's look at the first problem. This problem is based on a Telnet scenario which uses TCP as the underlying protocol. Now suppose that there are two clients A and B. Each of these attempts to open a session with a server S. Since transport layer uses TCP as the underlying protocol for Telnet, which uses port numbers, provide the answers to these questions. What are going to be the source and destination ports when a segment is sent from client A to S, from client B to S? And when the server replies to both of them, what are going to be the source and destination ports when server replies to client A and to client B? If we make some interesting tweaking and modification to the scenario under consideration, what is going to be the impact? For instance, if A and B are two different computers, is it possible that the source port in the segments from client A to S and from client B to S can use the same source port ID or source port number? If they can, or if they cannot, give a reason. And how is it going to change if both these clients are on the same host? For instance, two user applications at the application layer connect to the same server from the same physical IP address. Let's look at the throughput problem. Imagine transferring a large file, it could be a large video file, of L bytes from host A to host B. So it's a peer-to-peer transfer. If you assume a maximum segment size of 536 bytes, what is the maximum value of L, that is the file size, that TCP sequence numbers can support? Because you know that TCP sequence numbers are represented by 4 bytes. Now, the file that you obtain from the previous step, imagine transferring it between host A and B. You can assume that there is a total header of 66 bytes, including the transport, network, and data link layers. And the channel is a T1 link, that is 155 megabits per second is the maximum throughput that can be utilized. For the sake of simplicity, do not go into the TCP congestion control strategy, which is based on slow start and congestion avoidance. Rather assume that the transport layer or the TCP transmits it as a static window and sends packets or the segments back to back.